Hello, this one is problem 7 on assignment 8.2. And this is a case where we're supposed to figure out where to place an object in order for the center of gravity to be at 0, 0. And to start with, we have a 5 kilogram object placed at the 0, 0 position. We have a 4 kilogram object placed at the 3.4 meters 0 position, so it's at 3.4x 0y. And we have a 2.9 kilogram object at 0x and 3.8 meters. And with my numbers, I'm supposed to figure out where to place a 9.2 kilogram object in order for their center of gravity to be at 0, 0. The equation for the center of gravity is the sum of the mx's divided by the sum of the m's, that should say, not x. So sorry about that. That should be sum of m. And then that equation will give us the center of gravity. Well, we'll see that the 5 kilogram object is at 0x, so that's will be gone. The 2.9 kilogram object is also at 0x, so that one will be gone. And then we have 4 kilograms times 3.4x and 9.2 kilograms times x, divided by the sum of all the masses. So 5 plus 2.9 plus 4 plus 9.2. When we do that, we get 13.6 kilogram meters. That looks very similar to our torque units, except for it's kilograms meters instead of Newton meter, plus 9.2 kilogram x, divided by the sum, which turned out to be 21.1 kilograms. Well, we can take 13.6 divided by 21.1, and we end up with 0.65. And we can take 9.2 divided by 21.1, and we get 0.44. Then what we'll do is subtract 0.65 from both sides, and then we'll divide by 0.44, and we end up getting an answer of a negative 1.48 meters. So the object needs to be out here, a negative 1.48. And then going on to part B, we are supposed to find the center of gravity for y, the y position. This time I wrote the equation correctly. So it's the sum of my divided by the sum of m, so the sum of the masses. 5 is still at 0y, so that's gone. And now the 4 kilogram object is at 0y, so that's gone. So then we have, for our top values, we have 2.9 kilograms times 3.8 meters, plus 9.2 kilograms times y. And the sum of the masses is still the same, 21.1 kilograms. So then we divide through, and we end up getting 0.52 meters plus 0.44x. We will subtract 0.52 from both sides, and then divide both sides by 0.44, and we will get y equal to a negative 1.2 meters. And so then when we go back here, our object needs to be placed a negative 1.48 and a negative 1.2. And it'll be about right there is where the 9.2 kilogram object needs to be placed. This equation here, x center of gravity equals the sum of mx over the sum of m. That is the general equation for finding the center of gravity for any object. Thank you. I hope this video was helpful.